So I'm here with Anthony Cox, and he is going to be showing us this really cool house that he has. He's with Energy Solutions, and I'm super excited because he's pulling out all sorts of gadgets and gizmos, and can't wait to see what's going on with this. Okay, so hi Anthony, how are you?
I'm doing well. I'm glad to be here at the HVAC Symposium, just meeting a lot of folks and kind of educating as well, and just really enjoy doing that kind of stuff. So I have this little model house to kind of visually demonstrate stuff. And so just real quickly, the house here, this is like my main part of the living space.
Did you build this house?
I did initially. I've got another person that builds them now for me. So I'm like concept person. He's like finished carpenter, artist. You know, he makes it look good. I design it to make it work. So, yes. And I've had this for not this particular, and that includes things like exhaust fans, air handlers, combustion appliances, indoor air quality, comfort, about all of those things, and then just air tightness of the house.
So you take this to what kind of shows?
I take this, well, obviously this is an HVAC contractor, oriented, so the people that are doing the work at the houses. So really just getting them kind of tuned in to some of this performance issues, because sometimes it is things related to your HVAC system and your ductwork. Other times it's related to just the building itself. You know, maybe the building's leaky, or maybe even things like when your air handler, your furnace fan comes on and your bedroom door slams shut. You may see things like that or hear things, and why is that coming on? And so it has to do with like airflow for like what we call a forced air system, meaning that.
So your house isn't haunted.
Do what?
When your bedroom door slams shut, your house isn't haunted.
It's a what?
Your house isn't haunted.
Oh, no. No, it's not haunted. No. As far as I know, anyway. So, yeah, but it's all about moving airflow through the building. And so, real quickly, just talking about a heating or cooling, you might have a heat pump or a furnace, and I'm mainly talking about ones that have vents in the floor to blow air, not like boilers or things like that, but more like a gas furnace or heat pump, or even just an air conditioner. So they move air, you know, and basically I have my little furnace or air handler in the basement here. So this is what is a fan inside that gray box.
Okay.
And if you look up here at the top, this is what we call the return, and we have one return. So basically air comes from the house, goes to the box or the furnace, and then blows out through the red ducts, which are your supplies. And if you'll notice, in my house I have 3 supplies, or the red ducts, and only 1 blue duct, but it's much bigger. And they'll call that a central return. Now your home may have something like that. You're like where you change your filter. Sometimes it's in the house, you got a little grill that you open, and that's where you change your filter. Sometimes that might be in the floor, sometimes it might be in the wall, sometimes it might be in the attic. Just depends on where your duct is.
Now, is it possible that you could have multiple returns?
Yes, you could have multiple returns, and that might be that you have multiple returns on the same system, or you could have 2 systems in your house. You may have one downstairs and one in the attic. So yeah, you could have multiple systems in your home.
So is it important to keep those filters changed?
Yeah, the filters is important to keep them changed, you know, because that basically, if you have a dirty filter, you know, it can restrict the airflow. Basically, it slows down the airflow, and it just it doesn't allow your system to perform as well as it should. So it is important to maintain them, depending on what the filter is. Sometimes you might have just what we call a throwaway filter, which, you know, like a 1-inch filter. Sometimes you might have a better filter system, maybe have like a 4-inch filter. It just depends on what, well, really your house, and, you know, if you have pets and things and stuff, then you might have to change your filters more often, or just a type of filter. So just, you know, knowing what kind of system you have, or your HVAC contractor, you know, you might have to change it monthly, you might change it 6 months, just depending on what the situation is. And a lot of times in home performance, you know, I work what's called weatherization, which is a federal funded program. It's kind of where my background is. But a lot of times I get questions. I say, well, it depends, because it really does depend on kind of your house and a certain situation. But in general, like we said, this pulls air from the house, blows it back into the house, and as long as there's no leaks, you know, in the duct system, because it's pulling air from the house and blowing it back in, then it really doesn't change like the pressure in the house. In other words, like air moving in or out of the house, because it's moving indoor air. But sometimes your duct system may be an attic or a crawl space underneath your house, it's what we call unconditioned. In other words, you're not heating that space, but your ductwork runs through that space. But if you have leaks into those areas, it can actually change the pressure and cause air to leak in or out of your home.
So that means that it's pulling in air from your attic into your house.
It can, yes, or just leaks anywhere you have penetrations or leaks to the outside.
Okay.
Yep.
So you're talking about sealing up your house. Where are some important places to seal your home?
Yeah, well, you would typically want to start at the top of the house, because especially if you're, well, any kind of climate really, because even when you're hot in a humid climate, you got hot air from the attic. You don't want that getting into the house. And then in the colder climate, then you don't want leaks in the attic, because then air from your house is escaping out the top of the building and taking the heat with it. So it would take the air and the heat with it. And of course, the colder the climate, the more that would show up.
And what's your opinion about encapsulated attics?
Well, as you say, it depends, right? So if my duct system is in the attic, in other words, otherwise it would be an unconditioned space. If the insulation was on the attic and it had ductwork in the attic, it might be more beneficial to have your enclosed or encapsulated attic, because now your ductwork is inside conditioned space. Because even though you have ductwork, it's usually insulated to prevent condensation and stuff, but also to prevent heat gain in the summer and heat loss in the winter. So if your ductwork is inside a conditioned space, that's better than being outside conditioned space.
So your machines don't have to work as hard, and you're also not heating the outside.
Right, yeah, because if you have, like if I make a leak, for instance, so in my little house here, first of all, you see where the air's coming out here, and then you might can come around here over to the side real quick. But I can make a leak in this duct, so I can take this off, you see? So air's blowing out here. Now that could be in your attic, it could be in the crawl space, could be in the basement, but particularly if it's an unvented attic, or vented attic or vented crawl space, meaning those spaces are like outdoors. So if this is leaking into those spaces, then it's basically just blowing the air outdoors. So the money you're paying to heat or cool your house is blowing to the outdoors. Now, you know how I was saying that it was typically it's balanced. In other words, you blow the same amount of air in as you pull back. So if we go back over here to the house here real quick.
I see this device here. It has some numbers on it.
Yeah, so we're going to look at the number on the left where that green hose is. And that green hose actually goes to the outdoor of the house. It's actually outdoors here. And right now I've got the window off on the house. And I'm gonna put that leak back on that we had, just so I can kind of show you what it should look like. So basically we're measuring the pressure between inside the home and outdoors.
So that it should be at equilibrium.
Yes, so it should be close to zero, even when I've got my little window on here. So now the furnace fan or the air handler is on. I'm gonna turn it off just so you can see like when it's on versus off. So the number on the left, see, it's like 0.0. And I'm going to turn it on. That's a measurement of pressure. It's called pascals. So that's just how we measure pressures. But it's very small measurement. And so that barely changed it. It's like 0.2. Now, you can keep your screen here, but I'm going to go back to where we were before, make that leak.
Okay.
And so now part of that supply air or air that was blowing in is now going to blow into your attic or crawl space or wherever that leak is. And watch what happens to the pressure here. See how I changed the pressure?
Wow, it's a negative 3.6.
Yeah, exactly.
Negative 1, it's all
so it's making the house go negative, because if you want to back out here for a sec, so the air that was coming out of this vent is now blowing out into your attic or crawl space or whatever. But this return is still looking for this air, but it's not there anymore. So basically, you're sucking more air out of the house than you're blowing in. So that means that's why it made like a negative pressure here. And if I use my little smug pencil here, you can see that it's actually pulling air in through leaks in the building.
Through the outside. So if you have a humid condition, then you're pulling in all of that humidity.
Yes.
If you also any pollen or dust or debris.
Yeah, anything that's in that air. Because you might have a hole here, but when you do that, the pressure gets imbalanced, meaning that it puts pressure on this hole. And in this case, that supply leak is making the house leak. You know, and or some people will say, like, if you got a supply leak, it makes the building suck, basically sucking in air from the outside. And just like you say, anything that's in that air is now in the house.
It's in your house.
Right. Plus, it adds to what we call the load of the house. In other words, like that your air conditioner has to work harder because now you blew out your cold air and now you're replacing it with hot, humid air, which means you've got to re-cool that air. Plus, in a humid climate, you have moisture, and they'll call that latent load. But basically, it's just moisture. It's moisture just now being pulled into the house along with the heat, and now your system has to, well, remove some of that humidity because it's just going to make it sticky. It's going to make it uncomfortable.
So can I ask you, Anthony? So my company, I'm BPI certified, and we look at the building envelope.
Yes.
We also install the gray boxes outside. We do load calculations, and we're part of in New York State the NYSERDA program. For energy efficiency and also clean HVAC systems.
Yeah.
Why is it that a lot of HVAC companies don't do that?
Don't do these kind of measurements and things and stuff?
Or look at the building envelope.
Oh, right. Well, some of it they don't know that it affects things as much as it does. Now, they also get, sometimes they get the complaint, because my house is not heating well, or it's not cooling well, or it's too humidity, or maybe if I have I'll show you a return leak in a minute, but you could be pulling in smells and things and stuff from the house. So it's really just they get the complaint, but like you say, unless they've kind of educating themselves on this, because on this what we call building science, understanding that the house is a whole system. Yeah, I'm working on the furnace or the air conditioner, but all the other stuff is connected, and especially when you have a forced air, what we call forced air systems, moving air, then stuff can move with that air. It travels with the air, where it's heat, humidity, indoor air quality issues.
VOCs.
VOCs. Yeah.
This, you should not put garages in houses.
Well, if you do, you want a really good air seal, and you want the garage vented to the outside. So I showed you supply leak, right? I want to show you a return leak now. So I'm going to fix that leak that I made, okay?
Okay, so the return is the air being sucked back into the machine. So it's the blue part. Okay.
Yeah,
that's where the
that's this right here,
that's
right?
That big grill in your ceiling in the hall.
Yeah, it's basically in the house somewhere. You may have more than one, and this is what they call a central return. Now, some homes might have one of these in every room where you got supply. It's not as common. Northern climate, it's a little more common. Older homes, but it's cheaper and easier to just put one in the middle of the house.
Fan ducts in the house.
Right. Yeah, exactly. So anyway, you'll have at least one that pulls air back. Now I'm going to fix this back, and you can watch the. Well, actually, let me put this back on.
Okay, shutting the window.
Yeah. So now I'm going to fix that leak, and ideally that should go back to where it was kind of balanced before. Let me take it off. There's with it open, making a leak. And there's with it closed, so it's pretty much balanced again, right?
Yeah.
And so, if I draw this on here, that's like we said before. Now this air is coming in here, it's coming in here, it's coming in here, and then the return, even though I have only one of them, it's pulling back the equivalent amount of those three blowing in.
So it's balanced.
Yes. Now, let's say that I make a leak, like down here.
Okay.
So now basically some of this air is not going to be coming from the house anymore.
All right. It's being pulled in from the basement.
Yeah, wherever the leak is, right. In this case, it's like a basement.
So do you think people should store paint and stuff like that in their basement?
Well, the thing is here, if you have leaks, anything is, like in this case, it's a return leak. If you watch right here, what's happening to the air? It's going into the house. If it goes into here, that goes into your box there, and then it blows out into the house, right? Yeah, so if you have leaks, this is sucking air in. Now, this is where the leak itself is. And it might be an attic, crawl space, or the basement. But if you look at the pressure in the house, you see the pressure there now is actually a positive number.
Yeah.
Now, if I close the leak back, you can just watch the number, and you'll see, because it's going to balance out. And then I take it off, and you see it's unbalanced again. And the reason it's positive now is, remember, we've got all this air coming in, but not as much air coming out of the house. So it makes the house positive, so pressurizing the house. But that's what's going on in the house. But wherever the leak is, like I say, attic, crawl space, basement, anything that's in that area is now pulled into that leak.
So if you have positive pressure in your house, then you're just forcing air out of the penetrations to the outside and wasting all that energy. So
yeah, you can see that it's like really going out, right? And that's the same on these little holes as well. I just kind of made it a little easier to show. Yeah, so exactly right. That's pushing air out. But if your duct worker, this is called the return, it's pulling air in. If that's, let's say it's in an attic in Orlando, it's hot, it's humid, it's pulling in basically outdoor air if your attic is not encapsulated, if it's pulling it from the outside, or if it's a vented crawl space. And anything, not only the temperature and humidity, but anything that's in those areas as far as air quality issues.
Like mouse poop and
yeah,
spider
absolutely.
bits and all that stuff.
Anything that's in that space, right? I've had the ductwork go through a closet, and I went to a home, and they had said that their house smelled like cat litter. They couldn't get rid of the smell, so they had, you know, air fresheners everywhere. And so I said, where's your litter box? So I go find the litter box. It's in a closet. The ductwork runs through the closet, and it's got a big hole in it. So the litter box is right here. Here's a hole in the duct. Guess what?
Oh my goodness.
Yeah, it goes through that. So they didn't need to add all the air pressures. They needed to just fix the leaks, right?
Hole. You must have made them the happiest people in the world.
Yeah. And so a lot of things that in my world, weatherization, home performance, sometimes it is around energy efficiency, but a lot of times it's more just comfort, smells, moisture, and then when you fix those problems, you also get an energy efficiency benefit.
So Anthony, I use my house as an example a lot because it's a study in what not to do in HVAC, or is it HVAC or HVAC?
Yeah, either one.
Okay, so my kitchen is here, for example, and my bedroom is the low grade walkout basement is here, and the return is right next to my stove.
Oh, wow.
It goes through my attic, and then somebody put flex duct down to my bedroom. So I installed, see, you know what's happening.
Yeah.
So I installed one of those blue air cleaners in my bedroom.
Yeah.
The standalone ones, and it has built-in sensors for 2.5 VOC, you know, for
right.
VOC.
Oh, sure, yeah.
So every time I cook,
yeah, that thing goes off, or goes spikes, right? Yeah.
Spikes. And my bedroom, I like to cook with onions and garlic a lot.
Well, you're cooking again, we know it.
And my bedroom always smells like onions.
Yeah.
But before I got into HVAC, I'm like, I need to solve this mystery.
Yeah.
Why does my bedroom smell like onions?
Yeah.
So why does my bedroom smell like onions?
Because the air from the kitchen is moving, in this case, because you had a return in that kitchen space, probably not the best place to have it. Anything that's now in the kitchen is now goes through all the duct system, but you said in particularly that kind of went to your duct.
To my bedroom.
So maybe it's kind of like, you know, if someone's in that room, it's like, I know dinner's getting to be ready.
That is true. I mean, that's the benefit, but it does that even if I'm not using the fan.
Sure, right, because it's just naturally moving through there. So the best thing to do is kind of have the return somewhere else, not near that source. You know, yeah, you can try to dilute it by making leaks or putting air fresheners in, just like I was talking about the cat litter stuff. You know, it's really just how's it getting in there and moving to where you don't want it. You know, so it's kind of dealing with that. So on those lines, you know how he was talking about the garage a minute ago, right?
Yes.
So I have a little car in my garage, and so my car right here, it'll turn on.
Oh, that's so cute.
And I got a little car exhaust back here. So
not a good idea, right? People. Don't start your car in the garage.
Right, you do not want to do that. Now, we'll just stay on that because even if it's not in the garage, even if it's outside the garage, and the door is open,
the door is open here,
it can still go in.
Look where the smoke is. Look, the door is open. He's warming up the car because his wife doesn't like the steering wheel cold.
Yeah.
And look where that air is going, and what's in that air?
Yeah.
It's carbon monoxide.
Yeah, absolutely.
And you can't smell it, you can't taste it, and it is a killer. It is a killer. But look at that.
And if I close this door, make the house even tighter, now it's sucking on that even harder.
And carbon monoxide is also a very small molecule, and it can permeate cement walls. So it doesn't matter if you have a cement wall in your garage and a vapor barrier.
Right.
It could still leak into your house. So pull your car outside.
And close the door.
And close
after it's outside.
Don't put generators in your garage. Don't put grills in your garage.
Absolutely.
You can see here, look at that. It's just going on.
Well, it's going from there. Basically, it comes across there, and then it will come into here. Yeah, you can kind of see it's moving across there.
Yeah.
And so I would say even if your home is all electric, you still want to have a carbon monoxide detector.
Because if you're a cook like me and you get chicken grease all over your oven, you still have carbon monoxide in your house.
Yeah, so I'm going to turn the car off. Now, because like I say, one of the things that we're concerned about is indoor air quality, health and safety, and particularly carbon monoxide. So if you have combustion appliances, or in this case cars, you know, you want to make, if you have a garage and it's what we call attached garage, you definitely want to have any openings and penetrations between that space and the house air sealed or sealed up well, so it has less. But you don't want a connection between the garage and the house. And like I say, ideally, if the garage is detached, you know, it's a separate building, and maybe turn this into an extra bedroom or something.
Yeah,
but not that you have to do that. I'm just saying if you do. If you keep it in the house or attached, do some tests that they can do, air leakage tests, and making sure this is well separated. But like you were saying, start the car up, move it out, close the door, you know, even pull it away from the door a little bit.
So that also goes for any paints or solvents or things that you would store in your garage.
Anything that's in those spaces, you know, can be into the house. Yeah, and I know some people have either an outdoor shed, or if they have a closet in a garage, they might even have a ventilated closet. I don't see that a lot, but you can certainly have a fan that basically just pulls air and exhausts that fumes to the outside, so it's not coming in. But,
so it's not a good idea then to have your garage or that storage unit ducted with the rest of your house?
Right. Well, the garage, now sometimes I've got ducts that go through my garage.
What if I want heat in my garage?
And then you might want a separate system that's not tied to your ducted system. You might want a space heater or something like that. So now if you got ductwork, like in my little house here, that does go through the garage, and then the system's not in the garage, but you'd want that sealed. Now sometimes your furnace, your air conditioner is in the garage, or it's in a closet in the garage. So you want to make sure your duct system and things is sealed really well, because you don't want that to be pulled into the house.
Hey!
Yeah, I know, right?
How are you?
Good. Cool little
See you, John.
smokers.
Yeah.
I didn't know if you were filming or not.
Oh, I am. I'll give you a hug.
Hey, buddy.
John
I'm
Ellis.
Anthony. Nice to see you, John. Yeah, so we're talking about garages here, right? And we're talking about indoor air quality and stuff. So now, let's say that you do have a combustion appliance like a gas, or if you're in northeast, you might have even an oil water heater. Basically, they're combustion appliances. Now, older ones or common ones, they would take what we call combustion air. In other words, a fire has to have air to burn properly, right? They call it
air, fuel source.
Yeah.
And
ignition. You gotta have something to light it. You know, gas has a pilot light, oil has a burner. But anyway, you can see my little water heater's going here.
I see that. Yeah.
And that's what you want. You want the smoke to go out the chimney, right?
Okay, so there's no spillage. Well, no, there's a little bit of spillage there.
Yeah. The wind's blowing out here a little bit. Yeah. So now, remember I had this leak over here, right? But I got it. The space is really leaking. So maybe let's say I tighten the house up a little bit. Let's see what starts happening to that water heater now.
Look at that.
Yeah.
So remember we were talking about the positive pressure. This is positively pressurized, but look what's happening now with all of the smoke that's supposed to be going up the chimney. That also contains a lot of carbon monoxide, carbon dioxide, sulfuric
moisture.
Yeah.
Mm-hmm.
And that can kill you. I mean,
Yeah. Well, the carbon monoxide is the thing you're most concerned about. But like I say, you want the smoke to go up the chimney. But the reason it's not going up the chimney is that water heater is taking its air to feed the fire from the same space that this return leak is coming from. And so that's really, and if I, and sometimes, the house may have been leakier, and just sealing some holes and stuff, might make, even though I didn't touch the water heater, it's working now, and now I tighten the house up, so it doesn't mean you don't want to tighten the house up, doesn't mean you don't want to have combustion appliances, but you want to have your ducts sealed. Now, this water heater, like I say, is taking its air from the building, and you can have water heaters, if you want to stick with the combustion appliance, that takes its air to feed the fire. You know how I've got one pipe here that they have what they call a direct vent, which is kind of like they call it a concentric pipe. It's a pipe in a pipe. So one brings in fresh air and the other is your exhaust, but it basically disconnects it from the air inside the home.
So you shouldn't use your house air for combustion.
Well, especially if you're going to make it tighter, more energy efficient, because you're cutting down the air leakage into the house, or you may even have just a small space. So I'm going to fix this leak back. But what I want to mention, and that was kind of a good point though, but I can have a house that's, as far as air leakage goes, might be fairly leaky, but then I might have a laundry room or sometimes what's called a mechanical room where your furnace is in. So maybe in this case I have my dryer, and it could be just a little small room, and the wind's blowing over here. But so the smoke's going out, but let's say I turn the dryer on here, and then let's say this is the door to the laundry room. I know it's outside, but let's say it's the door to the laundry room. And then when I shut this door, let's see if it changes anything. The wind's blowing on me now. Oh, I gotta put this on because I got a big leak here. Now, let's see if that changes. Yeah,
Now
see there?
look what happens.
Yeah, so now where I've air tightened. Let's go back to this scenario. Say this is the laundry room door to the rest of the house. When I open the laundry room door, then the dryer actually pulls, because the dryer actually pulls air out of the house. You know, you feel the hot air going up, but it pulls air in as well. So if they're in the same space, even though the rest of the house may be fairly leaky, sometimes it might be a small room. And then when that door is open to the rest of the house, the dryer can pull air for your dryer to work from the rest of the house. If you close the dryer, laundry room door, sometimes that can starve this, the dryer for air, but so it gets its air from the chimney.
Wow, that's
So,
really...
not that every house has this or going on, but these are things you should be concerned about. What I'd say as far as like visual clues would be, like if you have like a gas water heater, they call it atmospheric, meaning it just pulls air from the house. Sealed combustion or direct vent, that means it takes air from the outside.
So if you have a direct vent appliance or a sealed combustion appliance, then you don't have the danger of this.
Right, as long as the
potential
pipes are connected and sealed well, then they're connected. It disconnects the air from the outdoors. Now, like if you had a gas water heater, for instance, and on top of the gas water heater, where your pipes come off the top water heater, they have a lot of times they have these little plastic rings right where the pipes go into the water heater. And if you see any signs of like melting and things and stuff like that, that might mean it. At some time, you know, the flue gases or the smoke coming down the chimney, and that heat is melting those rings. Or at the bottom of the water heater, you might see like some scorch marks or burn marks. Or maybe if you've got a gas water heater, you have to light it all the time. You know, what they call the pilot light goes out or something, and that's typically an older water heater. But anyway, I'm not saying you don't want combustion appliances. I'm just saying that if you do, ideally you want them from the outdoors. Just like we're talking about garages. Yeah, you can have garages. If they're attached, make sure they're sealed well. Better solution if it's not attached, but you know, that's not have to. It's just if it does, then you want to be able to deal with that.
Great.
All right.
Well,
I got one more thing I'm going to show you if you want.
Awesome.
Yeah, and you know how I was talking about like when you're...
Now, where's Christiansburg?
I am in Virginia, so I'm on the western side of Virginia, where Appalachian Mountains, Blue Ridge Mountains, Virginia
I'm from
Tech.
West Virginia.
Okay, yeah, I call it East Virginia. You know, all my friends in West Virginia call us East Virginia. So, anyway, so we talked about some duct leakage stuff here. So the last thing I want to talk about is like doors, like interior doors, and you know how like you may have your furnace fan, your air conditioner come on, and then the door slams shut.
It's not a ghost.
So, right, it's not a ghost like we were saying. So basically, how I was talking, the air's behind in the room, and if you only have returns in the middle of the house, the air's got to go from that room, and if the door's open, it can go through the door, you know, over to that return. But if the door's closed, or if you close the door, especially for long periods of time, this room gets pressurized. Basically, you're cutting off the supply air back to return. So if this gets pressurized, you can guess what's going to happen over here, is this may get depressurized. And so this room, if it does have one where you keep it closed a lot, or you hear it slam, you might see, like if you got carpet, you might see like dust or dirt stains on the carpet, and it's where air's been filtering under the door. Or the door jamb, you know, like the sides of the door. If the door is closed, same thing, you might see a lot of dust and stuff around that, meaning that air from that room is trying to get out. So you can do some testing and things and stuff, but they can put like sometimes they can undercut the door. They put like a little vent, or sometimes they can put a vent in the ceiling and what's called a jumper duct. So basically, you want the air from the room when we have a central return to get back to this main part of the house. You kind of air seal the outside of the house, but the inside, even though the doors are closed, you want them to act like they're not closed as far as airflow goes. And if I show you the pressure in there, I'm going to close the bedroom door here. So I'm going to close this door, and you can watch the number on the left.
It's closing the bedroom door.
Yeah. And you see it goes a little bit negative. Now I'm going to go over to the other bedroom door. I'm going to go right over here. And this door right here, I'm going to show you which one I'm moving right here, right? And I'm going to close the door, and when I close it, not only watch the one with the green hose, that's the pressure in this space. The one with the yellow hose is going into that bedroom. So this would be like putting a hose under the door. I'm going to close it. Look what happens.
Wow.
So the pressure on the green side, that's like this space. It's actually pulling air in, you know, through the leaks.
So that happened after they installed that plush carpet.
Yeah, right, because it can restrict the airflow. So basically, putting the plush carpet is now closing the gap under your door, which basically reduces the airflow. But anyway, so this part is blowing air in, and you're standing right here, and or put your hand right there. You can probably feel that. It's air blowing out on the hole right there. Yeah, hold it about like an inch away from the wall.
Oh yeah, I can
you feel it.
That. Yeah.
So this room is probably going to be hot and stuffy. This room, anywhere there's holes to the outside, it's pulling in. It's kind of like the duct leakage stuff we was talking about. But I'm going to, if you watch, I'm going to open this door just a little. And as I open the door, you'll see both of those numbers move closer to 0. See how that works?
Yeah.
Now, so you say, well, I don't want to leave my door open all the time. So what we'll do is we'll use a tool that the HVAC, something called a roomulator. Basically what you're trying to do is figure out how big the gap is that you made when you open the door. In other words, how many square inches that is. And then you can design, like I say, a duct to jump over the wall, go through the wall, or sometimes they might even add a return just directly to that room. And then that way when your door is closed, it would be more like this versus when it doesn't have that way for the air to get back, it would be more like that, which would be, this room would be uncomfortable, this room would be uncomfortable.
So if a room is hot and stuffy, you don't want to just dump more air into it.
Right, yeah, because it's got to be able to circulate through the room, you know. So if you're kind of you're what we call starving this return for air, because this air can't get back here, this is going to be sucking air in, this is going to be blowing air out, and those things.
So it's important that you measure that.
Yeah. So it might just
start putting more flex duct or a bigger.
Yeah. And if someone is what we call whole house or house of the system thinking, is that, okay, well, we're going to maybe air seal, maybe your house is leaky, and they're going to do some air sealing. They might do what they call a blower door test. It measures how much air is leaking. They find air leaks, so they might use what's called infrared. You've probably seen those thermal cameras that shows heat movement and stuff like that. So they might do some of that stuff, air sealing the house, or what we call it sometimes the shell or the envelope. There's kind of a lot of mixed terms there, but basically they're air sealing the house to keep the air from exchanging between indoors and outdoors. And then if they're working on your heating or air conditioning system, they may, you know, if the ducts are leaky, like we're showing leaky ducts, they may seal the ducts. And so that means it might be blowing more air into this room now. And then your rooms, like if you're getting a new heating or air conditioning system, they can do what they call a load calculation, or sometimes they say manual J. It's basically how big the heating or cooling system you need in your home. And then they can even get as detailed as how much air should be going into that room. So they can really seal the house, seal the ducts, get the airflow right to the room, and then figure out if they need to put a vent under the door or add an extra vent to that room. Because again, you're making that exterior tight and the interior leaky to itself. So, but that would a lot of times, you know, help with all those things: health and safety, comfort, durability. If you got moisture issues and things and stuff like, and then also energy efficiency. But a lot of times you're kind of dealing with those other issues. You get the energy efficiency for our benefit, but yeah, it's great because you get all of them. We call that house of the system. If you do one thing, it affects something else. And yes, educating the HVAC contractors, you know, more about the house stuff, you know, and they may get into doing some of the house stuff themselves, or they can work with, you know, someone that does what's called blower door air leakage testing or insulating and air sealing, and they might just, you know, partner up with them. So this conference is more about, you know, kind of, at least as far as me, is educating them on some of that house of the system, you know, theory, and then visually showing it so that they can get a better understanding. So when they come to your home, you know, they'll have a better understanding of the dynamic in your home and what might be the best solutions for your specific situation. As I say, it depends on the situation.
Great, great. Wow, that's so much great information, Anthony, and I love how you demonstrated it, and it's easy to visualize all the things that we're talking about, and that's awesome. Thank you.
All right, you're very welcome.